In this lesson, we're going to talk about some of the fundamental operations on sets: unions, intersections, and complements. We'll start with the union. So given two sets A and B, the union is the set of elements C such that C is in A or B. And remember, in math, whenever we say or, we always mean inclusive or by default. So it could be an A or B or both. And it's written with a cup symbol, which looks kind of like a U. And because it looks kind of like a U, hopefully that will help you remember that this means union. So let's take a simple example. If we have two sets A, which is 1, 2, and B, which is 1, 4, then the union of A and B is just a way to combine A and B. So you take all the elements and put them in one set. So 1 goes in the union, 2 goes in the union. This 1 is already there, but 1 is in the union, and 4 is in the union. So it could be in either A or B, or like the element 1, it's in both A and B. If you want to look at it in a picture, you could imagine, the way I've done this picture in the lesson is through an animation, but here, initially in the animation is the set A, it's this circle. So that's everything in A. And this circle here is B, and their union is just everything that's in A or B, or both. So the middle part here would be both. So you just essentially take the two sets and combine them, or union them together, as the word union would usually mean. Next, let's look at what intersection means. So the intersection of the sets A and B is the set of elements C such that C is in A and C is in B. So remember that in math, an and means both must be true. So I've had students get confused and think that union means A and B because you're combining both. But it's an or because it could be one or the other or both, whereas and implies that both must be true. The intersection of A and B is written with a cap symbol, which looks like an N, sort of. So here, for this one, you can remember that an N means intersection. So let's consider a couple of examples. If A is the set 1, 2, 3, and B is the set 1, 3, 4, then there's two elements in both A and B. There's a 1 in A and a 1 in B. There's also a 3 in A and a 3 in B. So A intersect B is 1, 3. The 2 in A is not included because it's not in B, and the 4 in B is not included because it isn't in A. So it's everything that's in both sets. It's where the sets intersect. And as a picture, here you can see A is this faded red circle, and B is the faded blue circle, and they're faded because they're not included in the intersection. And the intersection of A and B is only this middle part here. So that's A intersect B. That's not a very tight drawing, so it's hard to draw on this. But this middle part here is where A and B intersect. So it's elements that are in both A and B. The complement of a set A is all of the elements that are not in A. Remember that we always have this universe going on, so there's some universal set. And we really just mean all the elements that are in the universe that are not in A. So this is to avoid weird things where if A is the set 1, 2, and I talk about A complement, again, I don't mean my friend John is in the set A complement, because John doesn't exist in the universe of things we're talking about. Otherwise, we couldn't really ever talk about sets very conveniently, because the complement would always include all sorts of things that we didn't think about. So if we had a universe which was really small, so say that it's 1, 2, 3, 4, 5 is the set of numbers we're talking about, and that is the universe is 1, 2, 3, 4, 5, and A is the set 2, 3, 5, then A complement is everything in that universe that isn't in A. So everything in 1, 2, 3, 4, 5 that's not in A is 1, 4. And you represent the complement with this superscript C. So this is the complement of A. For a slightly more interesting example, if we let the universe be all natural numbers, that's the counting numbers, 1, 2, 3, 4, 5, 6, 7, and so on, and we let E be the set of even numbers, 2, 4, 6, 8, 10, 12, 14, and so on, then E complement is the set of odd numbers, right? Because everything, excuse me, all the numbers in the natural numbers that aren't even are odd, and that would be the set of numbers 1, 3, 5, 7, 9, 11, and so on. We can also represent this with a picture, but we need to make sure there's some bounding box that represents the universe. So in this picture, U is the universe, and that is everything inside this box. And A is this red circle, so A complement is the blue part. It's everything outside of that circle. So those are the three fundamental operations on sets.